Did you know that a landmark scientific discovery was first presented by one of the world's top scientists in this beautiful heritage building in the heart of Bengaluru? This is the Central College, set up way back in 1858. And it is in this very room on March 16, 1928, that CV Raman gave his first lecture describing his discovery of a new radiation that was later named after him, the Raman Effect. Raman did this scientific work in Calcutta, where he announced his discovery on February 28, 1928, and then traveled to Bengaluru to give a speech here to the South Indian Science Association. He used this desk and perhaps this board during his speech. This is a part of our scientific heritage. It gives me the goosebumps. He began his speech like this: I propose this evening to speak to you on a new kind of radiation or light emission from atoms and molecules. He was awarded the Nobel Prize for Physics in 1930, the first Asian and non-white to receive a Sciences Nobel. Importantly, he did all his education in India and graduated with a master's at the young age of 19. He did not play his tabla here, but it would have been perfectly appropriate because before he began his work on the physics of light, he was already internationally known for his work on the physics of sound. He had grown up in a musical atmosphere at his home, listening to his mother playing the veena and his father playing the violin, and he was intrigued by their musical quality. He was a precocious child, a prodigy, who graduated with top honors in physics at the young age of 16 from the Presidency College in Madras. And he actually got a scientific paper published in a British journal at the young age of 18 while he was still a student. In fact, it was the first such paper published in an international journal by anyone from Presidency College. His father was a physics professor, and young Raman used to ask him some really tough questions on physics. In fact, he displayed a huge curiosity in understanding natural colors and sounds from a very young age. After his master's in physics, he took on a job in the Indian Finance Service as an accountant. Yes, as an accountant. Because in 1907 in India, there were no jobs or careers in scientific research for physics honor students. And as part of his job, he moved to Calcutta, where he made his first important discovery, that India's first research institution was located in Calcutta, the Indian Association for the Cultivation of Sciences. And they permitted him to come in and do some research in his spare time before or after his office hours as an accountant. And this is where he spent several years in his early 20s researching and understanding the acoustics of Indian instruments like the tabla, the mridangam, the veena and the tanpura. You didn't know that, did you? Let's go to the science gallery to find out more. This is a Chladni plate invented by a German scientist Ernst Chladni in the late 1700s, where you can actually see sound. You can see how the powder settles on this vibrating plate, and these are the nodes where the vibrations are fewer, and this is where the antinodes, where the vibrations are higher. It helps you understand the natural frequency of this vibrating plate. This was the standard way to design musical instruments and for engineering the acoustics of concert halls. Raman used this very tabla, yes, it's his, to explain how a tabla creates rich tonal sounds. He was intrigued by its complex, rich tonal sound, and he used the tabla drum head like a Chladni plate and created so many modes of excitement or vibration and observed the different patterns, which was the vibrating frequency of the drum head. Raman observed that Western musical instruments were unpitched, flat, and in his words, musically defective. You can't really tune a drum to the pitch of the singer. A tabla, however, is incredibly versatile. Not only can you tune it to the pitch of the singer or the musical instrument, the player can create multiple sounds based on the placement of the fingers, the pressure exerted, or the manner of striking. He postulated that it's these multiple concentric layers of varying thicknesses, the complex tuning systems, and most important of all, this black circle called the syahi, all contribute to the rich tonal sound of the tabla. It's fascinating to see how this syahi is applied. It's made of iron filings, wheat powder and water, and the thickness of the syahi determines the bass frequency of the tabla. More specifically, he explained that the harmonic overtones in a tabla gave the same difference in pitch as a stringed musical instrument, and that the overtones were in integers, specifically the first, second and the third harmonic. This was due to the way the drum head and the drum was constructed, leading to a fine musical effect. And it's not just the tabla and the mridangam. He also did detailed observational work on both the violin and the tanpura, trying to explain how they produced a rich tonal sound. This work that he did in his 20s got him international recognition from the world's top physicists like Lord Rutherford, who was the father of nuclear physics, and set him off on his Nobel-winning journey. So is it for the science of music or the music of science? Sir CV Raman, we in Bengaluru are very proud of you. And this is how he ended his speech on March 16, 1928 in this room. We are obviously only at the fringe of a fascinating new region of experimental research which promises to throw light on diverse problems relating to radiation and wave theory, X-ray optics, atomic and molecular spectra, fluorescence and scattering, thermodynamics and chemistry. It all remains to be worked out.